Hey guys, so this is a video going over the homework of the evaluating trig functions with a calculator. So I'm going to be using this calculator because you type things in the same way you would as if you were using this calculator. Okay. I showed you guys how to use the Google calculator in the last video. So if you have any other calculator questions, just make sure that you ask me, and please make sure that you're getting the right answers, because if you're not checking that, then you won't know if you're doing it right or not, and then you're doing it blindly. Why do that? Because how do you know if you're doing it right or not? Like, that doesn't make sense. So please make sure that you're checking your work. All right, so number one, it says to determine each value, round to 3 decimal places. All right, the first one is cosine of 163 degrees. So first, I don't remember if the last thing I entered was in degrees or radians. It was in degrees, so I'm good. Okay, so cosine of 163, cosine 163 equals negative to 3 decimal places, 0.956. Okay. Number two, sine of negative 15.8. Sine negative 15.8 degrees equals to 3 decimal places, negative 0.272. Okay. Number three, secant of 18 degrees. Remember, secant, we don't have a button for. We only have sine, cosine, or tangent, but secant is the reciprocal of cosine. So I could type in my calculator 1 over the cosine of 18 degrees, and that will get me the answer I'm looking for. So in my calculator, 1 divided by cosine of 18 to 3 decimal places is 1.051. Okay. Number 4, cosecant of 3 pi over 7. Okay, now we are in radians. So that means I need to switch the mode in my calculator. So I'm going to switch it to radians. Okay. And cosecant is related to sine, so I'm going to have to convert this. It'll be 1 over the sine of 3 pi over 7. Okay, so my calculator, this is what I'm going to type in. 1 divided by the sine of 3 pi over 7. And we should get to 3 decimal places, 1.026. Okay, that was number 4. Number 5, cotangent of negative 1.3 pi. So I am still in radians because the pi is my huge clue there. But I don't have a cotangent button. Cotangent is the reciprocal of tangent. So I need 1 over the tangent of negative 1.3 pi. Okay, so my calculator, 1 divided by the tangent of negative 1.3 pi. Oops, did I type something in wrong? Let's try that again. 1 divided by the tangent, negative 1.3 pi. Oh, yeah, okay, I typed in something wrong. So negative to 3 decimal places, 0.727. Okay. Still in radians because there's a pi in there. Cosine of 12 pi over 13. So cosine 12 pi divided by 13 to 3 decimal places is negative 0.971. I have no idea what that noise was. Don't know if you guys even heard that, but it was really loud on the other side of the wall. I'm not going to worry about it for right now. All right, cotangent of negative 44.9 degrees. All right, we got to switch back to degree mode. Okay, I'm in degrees now. And cotangent is the reciprocal of tangent. So this is going to equal 1 over the tangent of negative 44.9 degrees. And that's what I'm going to type into my calculator. So 1 over the tangent of negative 44.9 degrees. To 3 decimal places would be negative 1.003. Okay. Number 8, determine the exact value. All right, so I'm going to highlight the word exact because now we need to be specific. That means that when they say the words exact, that means you're not using a calculator, you are using the unit circle. Okay, so the sine of 150 degrees, well, let's see if I can pull up my unit circle. I forgot that I was going to need it, so I'm pulling it up on my computer right now so you guys will be able to see in a little bit. Here we go. So sine of 150. Okay, so there's my unit circle, and 150 degrees is right here, okay? And I see the cosine is negative square root of 3 over 2, and the sine is 1/2. So the sine of 5 pi over 6, or 150 degrees, is 1/2. So on my paper, I'm going to put equals 1/2. So when you use the unit circle, you just have the answers right there. You just have to know where to find them. Okay, secant of pi over 2 is next. So secant is the reciprocal of cosine. So what is the cosine of pi over 2? And let's go ahead and find that on our unit circle. So cosine of pi over 2. So pi over 2 is up here, and the coordinate is 0, 1. So the cosine is 0, sine is 1. So cosine is 0. Okay. And when we try to find secant, so let me go back to the paper. Remember, secant is the reciprocal of cosine. So that means I have to put the cosine over 1, or so 0 over 1, and then flip it. But when I flip it, I'll have 1 over 0. Wait a minute, are we ever allowed to have 0 in the denominator? Nope. So that means that it's undefined there. Okay. All right. Cotangent of 7 pi over 3. Well, cotangent is related to tangent. It's the reciprocal of tangent. So let's find tangent first. So I'm going to switch you back up to my unit circle. And let's scout for 7 pi over 3. 4 pi over 3, 5 pi over 3. I don't have 7 pi over 3. Okay, well, how many degrees is that then? Or what is coterminal with 7 pi over 3? So what I'm going to do is I'm going to multiply. Let me go back to my paper. How many degrees is this? This is obviously bigger than the unit circle. So let's find how many degrees this is. Let's multiply by 180 over pi. Cancel out those pi's. So 7 times 180 divided by 3. 7 times 180 divided by 3 is 420 degrees. Okay, well, obviously that's too big. So let's subtract 360 from that so we can see what the coterminal angle would be. So 420 minus 360 is 60 degrees. Okay, so that means we're looking at pi over 3. Okay, so it's coterminal with pi over 3. So tangent of 7 pi over 3 is the same as tangent of pi over 3. Okay, let's take a look at that. So on our unit circle, pi over 3, I'm going to use this pointer my husband has. Pi over 3 is right here. And so the cosine is 1/2. The sine is square root of 3 over 2. So the tangent would be sine over cosine. So that would be, I'm going to go back to the paper. Sine divided by cosine. Oh, sorry. Like earthquake. All right, so sine is square root of 3 over 2. Divided by cosine, which is 1/2, but dividing fractions is uses pi. Flip the 1/2 and then multiply. So it ends up being just the square root of 3. Okay. Well, when I put that over 1 and flip it, because remember what we're supposed to find is cotangent. When I flip that, the cotangent of 7 pi over 3 is 1 over the square root of 3. Well, you can't ever leave a radical in the denominator, so we need to multiply top and bottom by radical 3, and we get the square root of 3 over 3. So the cotangent of 7 pi over 3 is square root of 3 over 3. Okay? All right. You know what I like about this unit circle? I just realized it. It has, if you see my mouse, who's over here? It has the cosine and the sine, but also outside of that coordinate, it has the tangent of each of these angles. So I like that it has all that. So if you wanted to add that to your unit circle and just find the tangent of every single one of your angles on here, you can add it in there. It's kind of nice to have, so then it saves you some trouble to do the work if you've already done it before. All right, that was number 10. Let me straighten this up. There we go. Okay, so there's no 11, 12, or 13. Don't know how that happened. I didn't create this, so, but although I've done that mistake myself before, so I can't say it wouldn't happen, but what can I say? All right, so the next set, starting at number 14, it says determine the value of theta, where theta is between 0 and 360 degrees. So I'm going to go ahead and highlight that. So this tells me that the angles that I'm looking for are positive and they're in degrees. And we need to find it to the nearest 10th of a degree. So we're rounding to the nearest 10th. So first of all, for number 14, we have the sine of theta equals 0.4067. So the first step that I'm going to follow is I'm going to solve for theta. I'm going to try to find the reference angle, which is also the first angle here. So theta is going to equal sine inverse of 0.4067. Okay, because we're working backwards. We're given the answer this time. Now we need to figure out what the angles were. So in my calculator, I should be in degrees, but I'm just going to check. I am, okay. Always check. And I need to hit the second button and then sine, so I can get the sine inverse of 0.4067. And I get 23.99. Okay, so to the nearest 10th, since it's a 9 and then there's a 9 next to it, it's going to go up to 24.0. So my first angle is 24 degrees. Okay. All right, how do I find the other angle? Well, remember, we have to draw a picture. So we know that the sine of theta is a positive value. Well, sine is positive in the first quadrant and in the second quadrant. So 24 degrees obviously is in the first quadrant. Okay, oh, let me zoom in. The other angle is got to be in the second quadrant, but it's going to be 24 degrees away from 180. It's going to be in here, and this is going to be 24 degrees away from 180. So to figure out this angle as it goes around from the positive x-axis all the way to this point, I have to take 180 and subtract 24. So 180 minus 24 equals 156. So the other angle is 156 degrees. I'm just trying to squeeze all my work in here. I might have scratch paper in case I need it, but I'm going to try to do all my work in here, which is why I'm switching the color for every problem. That and it's fun. All right, cosine of theta. So I'm going to start with the graphs this time because we have that the cosine is a negative number, negative 0.5023. Cosine is negative in the second quadrant. And cosine is negative in the third quadrant. Okay, so I'm looking in the second or third quadrant here. Okay, so I'm gonna have to find those two angles. I need to find the angle that opens up like this, and then I need to find the angle that opens all the way up like this. Okay, so to start that off, I need to find the original theta. So I'm going to have to take an inverse cosine of this, so negative 0.5023, and let's see what I get. So second cosine of negative 0.5023 to the nearest tenth would be 120.2. So my first angle is 120.2 degrees. Okay, so that's this first one right here. To find the next one, I know that it's 120.2 degrees away from that negative x-axis, so away from 180, but down here. So this time I have to add 120 to 180. And I'm gonna get 239, hold on, 180 plus 120.2 is hold on, I messed up. It's not. It is 120.2, that's one of them. But okay, so back up. 120.2 is over here. I forgot something. All right, so how did I get that answer? No, it is right. It's 230, or it's 300.2. Sorry, guys. No, because that's not in the... I need a bigger piece of paper. That's why I'm trying to cram this up on a small piece of paper, and I'm making mistakes. Okay, so this is number 15. Okay. All right, so let's back up a little bit. I made a mistake. So, and I knew that I made a mistake because I was getting an angle that's not in the third quadrant, and I know that it's in the third quadrant. Okay, so we know that one of the angles is in the second quadrant because that's where cosine is negative. So if we have our initial angle right here, and we found it to be 120.2 degrees. Okay. All right, well then we need to find the other angle, and we know that it has to be in the third quadrant because that is also where cosine is negative. So it's gonna be opening up and around, okay? And I know that this is 180, and what I need is the reference angle. So the reference angle is gonna be this bad boy right here. So I need to figure out what is this distance, and once I figure out this distance, then I know where it lands over here in the third quadrant. So what I have to do is I have to take 180 and subtract 120.2. That's what it was. There we go. 59.8. So this angle ends up being 59.8 degrees. Okay, so now that means this reference angle opens up 59.8 degrees down here, but the whole angle all the way around on this side is going to be the 180 plus this little piece right here that is just 59.8. So 180 plus 59.8 is the next part. So I'm typing that in my calculator as we speak. And that's how I get the 239.8. Okay, so that's my other angle. So sometimes we just need a piece of scratch paper. So 120.2 and 239.8 degrees. All right, number 16. What color am I on? I'm on the darker blue. All right, number 16, tangent of theta equals 2.9988. So first of all, tangent is positive. So tangent, remember, is sine over cosine. So that means that either both sine and cosine need to be both positive or both negative, because a positive divided by a positive is still positive, and a negative divided by a negative is positive. So that means we're dealing with an angle in the first quadrant and the third quadrant. So our angles are going to be up here and down here somewhere. Okay, so let's find the first angle. So theta is going to equal the inverse tangent of 2.9988. So my calculator, second tangent of 2.998, oops, 9988 equals 71.6 degrees to the nearest tenth. Kids are playing on the swing outside. That's why you hear them giggling. Okay, so that's the first angle. So that's the one in the first quadrant. There's our 71.6 degree angle. Now we need to find this one. Okay, well, we know since this one is 71.6 away from the x-axis, that this one should be 71.6 away from the x-axis. So we literally just have to add 180 plus 71.6. So 71.6 plus 180 equals 251.6. And I'm going to go get up real quick and close the door because the giggling is distracting me as I trip on my way out. Okay, try not to trip on that cord. All right, sorry about that. It should be a lot quieter now and I should be able to focus. Whoa, I didn't want to do that. I didn't know I could even do that. Learn something new every day. I guess I could face myself. Didn't know that. Okay, number 17. What color am I on now? I am on purple. Oh no, I'm on teal. What am I thinking? Secant of 1.1111. Okay, secant is related to cosine, and cosine is positive in the first and fourth quadrant. So we know the angle's got to be here and here. Okay, so let's first find this angle. So, so theta is going to equal the secant inverse of 1.1111. But we don't have a secant button on our calculator, so I'm going to have to type in cosine, because it's related to cosine, but of 1 over 1.1111. And let's see what that equals. So second cosine of 1 over 1.1111. And I get approximately to the nearest tenth, 25.8. 25.8 degrees. That's the first one. Let's find the other one. So that means that this angle right here is 25.8 degrees. And it's 25.8 away from the x-axis, which means the one down here is also 25.8 degrees away from the x-axis. But all the way around, to figure that angle out, I just have to take 25.8 and subtract from a full rotation, which is 360, since this angle is closer to a full rotation. So 360 minus 25.8 is 334.2. degrees, and there's our second angle. So the trick is it's always in reference to an x-axis, whether it's the positive side or the negative side. That's how you find the second angle. Okay. All right, number 18, and we're gonna make it pink. Cotangent of theta equals negative 1.2222. Well, cotangent is related to tangent. It's just cosine over sine, and it's negative. So that means that either one or the other, sine or cosine, needs to be negative in order for cotangent to be negative. So I'm out of room to draw a graph here, so I'm going to go ahead and go to my scratch paper. So the only quadrants where a cosine or a sine, just one or the other, is negative would be in this quadrant and in this quadrant. They're both positive in the first, they're both negative in the third. So the angle has got to be in here or here, okay? So we need to find the initial angle. So we're gonna find theta, and theta equals the inverse cotangent of negative 1.2222. We don't have a cotangent button though, so we're gonna have to convert this to tangent. So the tangent inverse, but tangent is the reciprocal of cotangent, so it'll be tangent inverse of 1 over negative 1.2222. And let's see what we get. So second tangent, 1 over negative 1.2222. And I get negative 39.3. Okay, so that means that it is 39.3 degrees away from an x-axis. Okay, so that's not one of the angles because this angle has to be positive. It has to be between 0 and 360. So this one throws us a curveball. But I know that the angle is 39.3 degrees away from the x-axis here and 39.3 degrees away from the x-axis here. So that's going to help me find these angles. So to find the one in the second quadrant, since it's 39.3 degrees away from 180, I just have to take 180 and subtract 39.3. 180 minus 39.3 is 140.7. So that's one of the angles. Now this one is 39.3 away from this x-axis, which is closer to the 360. So I have to take 360 and subtract 39.3. Which is 320.7. So those are my two angles, 140.7 and 320.7. So 140.7 degrees and 320.7 degrees. Okay. All right, on to the last part here. Remember, we get to skip number 22, so don't worry about that one. Okay, I am on purple now. All right, it says determine the value of theta where theta is between 0 and 2 pi. Okay, so we're basically doing the same stuff, but now we're dealing with radians, and they've got to be positive radians. To the nearest hundredth, so that is 2 decimal places, hundredth of a radian. Okay, so that means I got to switch my mode to radians in my calculator. Okay, and okay, so the sign is a positive 0.8143. So I know that sine is positive in the first quadrant. So I'm going to have an angle in here. And sine is positive in the second quadrant. So I'm going to have an angle in here. Okay, so let's find the initial angle. So theta is going to equal sine inverse of 0.8143. So second sine of 0.8143 to the nearest hundredth is 0.95. So this first one opens up to 0.95 radians. The other one opens up because it's 0.95 away from this x-axis, so it will also be 0.95 away from this x-axis, but that x-axis is at pi. So what I have to do is take pi and subtract 0.95, and that's going to give me the other angle that opens up from here to here. Okay, so second pi, not plus, minus 0.95 equals to the nearest hundredth 2.19. So 0.95 and 2.19 radians. Okay. Number 20, cosine of theta equals 0.7838. Okay, well, where on the graph is cosine a positive value? Cosine is positive in the first quadrant, so we'll have an angle in there. Cosine is also positive in the fourth quadrant, so we'll have an angle in there. All right, let's find it. So theta is going to equal the inverse cosine of 0.7838, and let's see what that equals. So second cosine of 0.7838, making sure I'm typing that in right. And to the nearest hundredth, I get 0.67. Okay, there's one of them. So this one opens up 0.67 radians. This one goes around, and it is also 0.67 radians away from that x-axis there. And at that x-axis, it is 2 pi. So to figure out that this angle all the way around, I have to take 2 pi and subtract 0.67. So 2 pi minus 0.67 equals 5.61. So this one is 0.67 and 5.61 radians. Okay. I skipped some colors, so I'm gonna go to red. All right, number 21, cosecant of theta equals 1.020. So cosecant is related to sine, and this is a positive 1.020. So sine is positive in the first quadrant and the second quadrant. So that's where this angle could be. So let's figure out our first angle. So theta is going to equal the inverse cosecant of 1.020. But we don't have a cosecant button, so we have to convert this to sine. So sine inverse of 1 over 1.020. And let's figure out what that is using our calculators. Second sine of 1 over 1.020 is 1.37 to the nearest hundredth. Okay, so this first one is 1.37. So to find the other one, I know it's 1.37 away from the x-axis, so it will also be that same distance away from the x-axis in the quadrant 2. So I have to take pi and subtract 1.37. So pi minus 1.37 is 1.77 radians. And that's the homework. So I hope this helped. Please let me know if it helped or not. I'm doing this video in a different way. I'm using YouTube instead of just uploading into Google Classroom, because when I do that, the phone only lets me do like 10-minute increments in videos, and this way in YouTube I could just do it all in one whack, one video. and it's only 35 minutes long. So anyways, have a good one, you guys. Let me know if this helped. I need positive feedback just like you guys do. So give me that positive feedback. I need some sort of positive interaction in my life. But anyways, I love you guys. Have a great day, and I'll see you in my next video.